I'll let you do it. Okay, where's my... Well, welcome to the July, get it right, 19th, 2022 session of TangerineSDR and Hamside technical sessions. My name is Dave, KV0S, and this week I've been working on some RTL SDR stuff and working on interfaces to data and trying to get myself back into programming more. I'm also doing a fair bit of 3D printing, so making a new antenna. So that should be fun. So that's it for me. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. It's been a very busy week. I'm trying to do some coding for plots for a paper I'm working on with Christina with the grape. Been working with Bill Engelke and the TID group on going forward with the traveling atmospheric disturbance science. I'm trying to work with Francis to get some code up for looking at traveling atmospheric disturbances with SuperDarn. Let's see. Jonathan Rizzo and Bob Spalletta came over to my house on Saturday, and we installed a new GNSS timing antenna here that we now have hooked into Jonathan's VLF receiver. And then hopefully on this Friday, he'll come back to my house and we're going to work on connecting that up to all of the science receivers here. I'm trying to work on getting the contract in place to actually do the antenna and new station installation at the University of Scranton. So I'm trying to work through that paperwork. And we're trying to get the new GRAPE grant off the ground too. So there's a lot of stuff going on and trying to keep all the students going. And next week, we're going to have this Radio Blaster physics camp at Scranton, which Scotty attended last year. We're going to do it again. We'll have about 10 high school students come. We're going to teach them about physics and ham radio and all sorts of related things. W2NF, back to net.
Well, very good. Next on the list, we have Bill, AB4, EJ, sorry, Bill.
Thanks, Dave. Good evening to you. Good evening to the net. I've been working very frantically on trying to clean up lots of dangling issues with the central control system for the personal space weather station project. And I think I've got it ready to where we can, by the end of this week, have our first beta tester, which I think is probably going to be Nathaniel, uploading from his magnetometer to the central control system. I mean, I've had mine running for a couple of weeks, but I want to get another participant and see how that goes. So that's where we're at. Back to net.
Well, fine business. And next on the list is Bill Kelsey. Go ahead, Bill.
Yeah, getting all hooked up here. I just got back from vacation yesterday, so don't have anything to report. And as you can tell, I'm still trying to get things back in place. I don't even have a radio back on the bench, so we'll sit and listen this week. Back to you.
Well, fine business. It looks like you succeeded in relaxing.
I relax, yeah. Now I got to recover.
Okay. Next on the list, we have Dan in for XWE. Go ahead, Dan.
Thank you, Dave, and good evening, everyone. Not a lot to report. I did work on scripts a little bit last week, and I've caught a couple of things up that had been surpassed by revisions, and that's really about it. I'm currently in Huntsville, Alabama, and we'll be here for at least 2 more weeks, and then I'm not sure where I'm going to be after that. So back to you, Dave.
Well, please keep checking in so we can follow the adventures of Dan.
Okay, thanks.
So next on the list, we have Dave, KD0EAG, and I believe you had some adventures the last 2 weeks.
Oh, none only the ordeal of the airlines, and I did get to see the hotel that the DCC convention is going to be held at from the parking lot, because even though I was trying to travel from Albuquerque to Kansas City, I managed to end up in Charlotte, North Carolina, even though it was nowhere near any place I wanted to be. And now it's taken me really a week to even figure out what I was doing before I left. It goes round and round and round. But anyway, I haven't accomplished much, but I've not for want of trying. Over to you.
Okay. Next on the list is David in 1HAC. Go ahead, David.
Good evening to the net. Let's see. Well, finally, hopefully got the last piece of our Baffin Island project shipped off, and that should be being installed by the University of New Brunswick in a little bit. Been working on our Antarctic solar power project. Going to be doing, current part is doing radio interference testing on the wind turbine and charge controllers and all that. See if they're quiet as they are said to be. But we know that one man's quiet, it's another man's raucous noise. So we'll see how that comes out. I guess that's about it on this side. Back to net.
Well, very good. And let's see. Next on the list is Hyomin Kim, KD2 MCR.
Yep. Hello, everyone. Yeah, I've been pretty busy doing mainly taking care of our summer internship program called REU, Research Experience for Undergrad Students. I just overheard that you guys are mentioning Diego, and actually Diego is actually conducting his research under my supervision. I would say he is the most relaxed summer intern student, because except for him, the rest of the students are the first timers. So they've never done like research before. So some students are very nervous about what they do. They're very new to all kinds of presentations, oral speech skills and stuff. But Diego is just, he knows what to do. He already has done a lot of presentations. So he is the most easy student that I can. So at the same time, I kind of felt that I don't really take care of him that much. While all the mentors are super busy, like taking care of their students, because the students has never done such a thing before. So I'm very lucky in that sense. He's working on two things which are related. One thing is actually ham-side magnetometer data analysis. The other one is actually magnetometer analysis, data analysis for interhemispheric studies, which are very tightly related. So he's moving along, doing very well. The good thing about being part of the REU program is that we will be sending all the REU students to BBSO and Owens Valley Solar Radio Observatory next week for the whole week. So they're very lucky enough to see all this cutting edge instrument facility there. So yep, that's about it. So back to the net.
Well, fine business. And next on the list is James, KG4 DSG. Go ahead, James.
Good evening, Dave and the group. Not much going on this week here. I'm just trying to rebuild an old laptop, and Fedora's giving me fits. So with that, back to the net.
Well, good luck with that. Next on the list is Jim, K4 BSE. Go ahead, Jim.
Good evening, all. I, like Dave, I'm just back from a vacation week of lying on the beach. And so I've got to be retrained and review this electronics mystery that I haven't touched in a week. So I'm just getting back into retraining. That's about it.
Okay. Next on the list is Joe, W7LUX. Go ahead, Joe.
Good evening, everyone. Very, very busy here, but not much related to HAMSI, except the grape is chugging along, recording data, and hopefully Veronica can find some use for it. She's on some kind of a experiment here this evening. And we've got yet another fire up here. This one's about 10 miles south of me, and of course, that's the way the wind blows, so kind of keeping a real close eye on that. Thanks, Dave.
Okay. And next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I had a fairly busy week today, a fairly busy week. I was working more on my 3-channel VLF system. I was getting more components on the board soldered, and I was also working on the H-field receiver. I was able to get access to a circuit board cutter, and I cut the right size copper clad board for the H-field receiver. I also cut the boards for the shark fin module for the hammerhead seismometer. So Bill, I have a board ready for you. Just give me your address and I will mail it to you, so you could populate it and test it out. And as Nathaniel said, I was down his house with Dr. Spalletta, and we installed a Trimble Bullet L1, L2 antenna. We used brackets for TV antenna masts, those wall mount brackets, and we used a pipe, and we were able to put the GPS antenna up, and it's a pretty good performer. It's still by a tree, but it's working really well. And also I finally got a chance to fix the GPS problem in my VLF system. It was weird because the Trimble module, I was able to talk to it using Trimble Visual Timing Studio. That's the software that Trimble provides to talk to their GPS modules. And I was able to pull up its serial number and hardware revision and firmware version and all that. And I could communicate with it fine. But for whatever reason, it just would not go into timing solution mode. It would not get a position. It would just nothing. And I don't think it's the antenna circuit, because the way it's set to is if it has a bad signal, it'll still output a pulse per second signal, but it wasn't outputting anything at all, which was really weird. And it just, I mean, it was almost like it was dead, and it wasn't. I tried factory resetting it a couple times, but nothing happened. It did not make a difference at all. So I'm going to go to Trimble to see if I could get some support on it. Maybe they could investigate it and fix it. I'm also going to go to Trimble. I'm going to continue the ticket that I opened about the pulse per second jitter that I experienced last year. Now that the GPS antenna is up, and I could verify that even with the backup Res 360 module that I put in the VLF system, that PPS jitter problem still happens with marginal signal. So I think it might even happen with the outdoor antenna, but I need to investigate that further and let it run. Other than that, that's all I have. Back to the net.
Well, fine business. And next on the list is Jules, K2KGJ. Go ahead.
Hi, Dave and the group. Nothing particularly new here this week. Yeah, nothing to report to the net anyway. Back to the net.
Well, glad you're here. Next on the list is Noel Pettit, WB0VGI. Go ahead, Noel.
Good evening, everyone. Just reburied the 2 sets of magnetometers that are running off of the IC magnetometers. One is the RM3100 and the other is FLC100. And so if anybody needs magnetometer data, it's live coming from my magnetometers. I can send it to you, or you can just take it off of Google Storage, or I can just direct it to you. There, it's also showing up on Adafruit's IO pages, and I think I've sent that list out. So those seem to be running well. Made some changes, and now we'll see how that stabilizes out. Thanks, everybody.
Very good.
If I'm not mistaken, I believe Dave Whitten is collecting, well, is running a data server where we are collecting all the data sets. Is it still the case, Dave? Then can you push data to Dave Whitten's server so we can have data sets in one place?
Oh, I mean, that'd be great. Yeah, just tell me how to do it. I'd be glad to do it. I've got a Google server running, and I've also got can send it to it in any other format you want, or you can just buy it off of either one of the servers that are running out there. So
I don't know if we have to pull the data or push the data. I don't know. Dave, do you have any idea?
I would be happy to work with Noel to see what might work for him, and that would get it up there. It's nice to have an extra backup always, I think, for anyone. And I do have instructions on how we're doing the RM3100s as it is. Other data, almost any data probably could be somehow pushed up there, and I can arrange that. So if either I can contact you or you can contact me, Dave Whitten, KD0EAG, and we can work that out if you'd like.
Right, I have your email, Dave. You've gotten lots of copies from me, yeah. And I just had to wait till summertime so we could dig up the magnetometers and put them back in the ground again.
I know.
What are you running for cycle count? No.
They're running right now. They're running 1 minute or 1 second.
No, I mean this. I mean, what are the parameters of the RM3100, namely the cycle count?
It's running in its base mode, which I think is 200 cycles. Isn't it? I didn't.
Yeah, you'd be better off running it at 400 if you could do it.
Right. Well, I wanted to run it as naked as possible so that there weren't any changes going on. But I can change it or just average them. They're working just fine right now.
Well, Dave can fill you in on the typical settings we use anyway. So when he communicates with you, you can talk with him about it. Right,
Dave. So you have my email, so you can send me the information. I'll happy to send it off. Like I say, it's going to Google right now. It's also going off to the Adafruit server.
I'll try to get in touch with you tomorrow about
that. Yeah, thanks much. If you send it to me, it may take a couple of days, but that'll be fine. Great.
Okay, next on the list is Terry, W0ASP. Go ahead, Terry.
Oh, hey, Al, W0ASP here in Colorado. Just kind of lurking and seeing what's going on with the project.
Very good. I don't think your background picture is in Colorado, though.
No, that happens to be in Antarctica.
Yeah, I assume so.
I've been there, done that.
Well, glad you're here. Next on the list is Tom, N5EG. Go ahead, Tom.
Okay, good evening, Dave, everyone in the group. First things, Nathaniel, congratulations on getting all the scholarships for your crew there. That is such an outstanding program.
Thank you.
To get good research work, to get scholarships, and to tie it all into ham radio, that's just a really outstanding project. So congrats on that.
Thank you.
And this week I got airfare booked to DCC, so that's about it. Back to the group.
Well, fine business. And I believe nobody's jumped in there. I don't see Scotty at all. I did want to tell the magnetometer folks, I had a suggestion of somehow capturing the command line switches for our magnetometer settings and putting that in the metadata. And I have, if you look at my KV0S site metadata, I have an example there. So if anybody else wants to try that, you're welcome. But it's just basically recording the magnetometer switch parameter settings so that they're available for whoever's analyzing the data. Anyway, that's it.
What parameters are you referring to?
The parameters that you would have on the command line, I put a copy of them in the metadata along with the latitude and longitude coordinates.
Oh, okay, I see.
So we put metadata in each directory so that you knew where the places were. I thought it'd be good to save the parameters of how we collected the data in there, would be useful to whoever's using it.
Right, that should be useful. Yes, yeah, along with the location information.
Yeah.
Yeah.
So it's a straw dog to get people to start to do something like that, but that's all that is. So we're open for general discussion.
Just one little point. I spoke with Dave Witten about this. There is a race condition in the original software code. So instead of getting 86,400 samples like you should get, 1 per second, you get about 75,300. And I developed a version of the code that does a different approach to the timing that does produce the 86,000 per day. And the reason of it was the original code does a 1 second or whatever you put, however many milliseconds you put in your parameter. Typically you put in 1,000, which means a 1 second delay, but that doesn't take into account the processing time. So you're going to skip a second every so many seconds. So anyway, there's an alternate version which I sent to Dave for him to study that uses a different timing. You get to the end of the main loop and it just waits for the top of the next second to come around, but it is fixed exactly 1 sample per second. It's not adjustable. So that parameter with the delay at the end, it just gets ignored in that version. But when I've spoken with Nathaniel's belief was that 1 sample per second was what we need. So anyway, that Dave has that and he's going to study that and come back with some comments on that. But Anyway, that's a little bit, something that people should be aware of, that the current version, if you use the standard parameters, doesn't really give you exactly one sample per second. So
I was actually working on that today. I just haven't put, I wanted to diff it with the original just to be sure I didn't miss anything you put in there. And my best editor for doing that is mysteriously out of whack. But I was working on that today. I hope to get it fixed. That was in a way a problem I was aware of, and addressing from a different angle, but that was a good catch too, because I really hadn't thought about how to force it to make that code work right. I just knew that code I wasn't happy with it. So that's why I've been working on these much more deterministic little Arduino kind of things to read using and timestamp at the thing and be able to use partial seconds and hopefully even two samples per second and stuff like that from the source out in the woods or wherever it happens to be. So, but I have wasted an immense amount of time and taken two vacations that completely sent me into, tailspins. And not quite gotten that bit accomplished or finished. It's close, but it's not. But anyway, for most people, that's a better solution. And I hope to get it posted soon. And I will try to announce that at least to the TangerineSDR list, that people should be aware that there's an update to that code.
Yeah, there's more than one way to do that for sure.
Yeah.
So, yeah.
Bill, my code all uses the Adafruit Python scheduler. So it's just the scheduler is set to go at the 0 time of every second. So I don't care how long the process takes, but instead of putting a time delay in, I just use the scheduler, which starts something on the second every time.
Yeah, Jules had some things that did that rather nicely too, and I probably should have pursued it more, but I was working in C, and I had grander designs, but as usual, they have led me into the dark woods.
Well, I figured that Dave would get it straightened out, eventually, because the C program offers a lot. But in the meantime, in order that I could do my testing here right, I did mine in Python. 2 different methods, one using a scheduler and the other one actually using a GPS interrupt from a 1PPS GPS. So I have 2 different versions of the programs running on the 2 different magnetometers. But that was basically just so I could get a known cadence that I could do some testing with. And I figured eventually that you'd get the C program working with that capability.
Yeah, we'll converge on something, but I don't want to hold anybody up because I'm, trying to perfect something that nobody's really asked for. So I will get that code up, and Bill's suggestion seems to be very good. That scheduler is very nice. I didn't use the Arduino one, but there was another one, or the Adafruit one, but I experimented with the other one that Jules was using, and it's very nice for giving pretty accurate stuff at the level we needed. But you're using the operating system resources, I think, to do that, and I wanted to get it into a standalone collection board where any perturbation, even the timestamp would be on there at the source. I'm just probably being a little obsessive, I guess. But
well, I think that's reasonable. That's kind of why I went to the one PPS GPS signal for the time marks. just for that reason. You know, wanted to be as close as I could possibly, same as you were doing.
Yeah, I think, honestly, I think we can get the kind of precision we want for this purpose using either the DS, what is it, 23, you know, the timer chip, a GPS pulse per second, or even the Arduino's counter with I think we can do it any of those ways depending on the demands of the use. But I guess I got a little carried away.
I have a question. Dan and I have been getting emails from Scotty off and on, maybe Nathaniel as well, but does anybody have a report on what Scotty's up to?
I have not talked to him in the past week directly, so I think I need to contact him again. But he's supposed to be testing the boards and then sending them out very soon. I know he was tied up with trying to get his house cleared out so they could take pictures of it. And I looked on Zillow tonight, and I know where his house is. So I looked, and there are now photos of the inside of his house. It looks very nice. There's a really nice patio that goes out to the pool, and it looks very attractive. And I think it should also get posted on hamradiohomes.com because it has power there as well. So hopefully he's moving along with that sale. So hopefully we can get him to send us the boards now.
Yeah, I texted with him today, and I think he's just like really, really busy with the house stuff. And not only is he trying to sell the old house, they're trying to build a new house.
I know.
Making a lot of effort.
Yeah.
And there are lots of tapper things going on right now too. So getting ready for DCC and the like.
Yeah.
So a lot of things to keep him busy.
I was wondering if I could talk to Jonathan for a moment.
Go ahead.
Jonathan, those problems you're having with GPS, could you run through that again? Your pulse per second stuff?
David, can you repeat that, please?
I'm wondering, what are the problems that you're having with pulse per second from your GPS receiver?
Well, this seems to be specific to the Trimble Res SMT 360. And what would happen is during marginal signal conditions, the rising and falling edge of the pulse per second would actually jitter between consecutive pulses by 1 millisecond. And so when VT time, it expects a pulse per second at a certain time, and because of this jitter, it's out of that window, and it won't actually record it. Now I've talked to Trimble about this jitter, and they seem to think that the problem is with the antenna or the marginal signal, and you should have an outdoor antenna and this and that, and they're right, but that pulse should never jitter.
That's not strictly true. And also, you said that you had problem with it coming up with a 1 pulse per second. Sometimes it wasn't giving one.
Well, that was when something happened to the module.
Well, two things I'll mention. One is I don't know about this module, but a lot of receivers won't give a pulse per second until it gets a good lock.
Well, this one will do that by default. However, I set it to output a pulse per second, even if it doesn't have a good lock.
Okay.
And
the other part of it, though, in terms of jitter, is I've had that happen if it has a bad location. How have you determined its location?
Well,
you do a survey, or do you give it what you think its position is?
No, it just acquires the position by itself.
Okay, because I've had had receivers that I've brought up in one place and then I move them to another place, and it has the old location in it, and it doesn't realize that it needs to do a new survey, and I will have that problem where the pulse per second will jitter around because it's trying to figure out where the satellites are relative to it.
Well, see, here's the thing. If I disconnect the antenna, and since it's still outputting a pulse per second, that pulse per second will never jitter with the antenna completely disconnected. No,
right, but it will drift.
Well, no. Right. It'll drift, but it doesn't drift enough where the software doesn't see the pulse. Now, when I plug it back in, when I plug the antenna back in, it will go back to jittering, either the rising or falling edge or both. And I've talked to Trimble about this, and they don't seem too interested in trying to solve the problem. Because I would think that even under bad signal conditions, a timing receiver, which they sell as a timing receiver, should have a stable pulse per second. And when it jitters like this, it could cause issues in certain systems.
Now, what have you been using for an antenna?
Well, before the bullet antenna, I was using an indoor puck antenna from Trimble. It was an L1 antenna only.
Right, and indoors, and probably pretty poor signal.
Yeah, there were times when the signal was poor. I mean,
have you been keeping track of how many satellites it sees?
Yeah.
Does it jitter when it's got a low number of satellites?
Well, there's no like it can have, I don't know, 6 usable satellites, and there'd be no jitter. And then later on in the day, a couple hours, you could have 9 usable satellites, and it could be jittering.
Okay. Sometimes, again, if it's got the position a little bit off, the satellite configuration makes a big difference. Sometimes, like, they're all just overhead. Sometimes they're on the horizon. Doesn't have a good way of getting a good average between them. But is it better with a roof antenna, or you haven't gotten that far?
Well, so far it's been pretty good with the roof antenna. Before I connected the roof antenna, I was experiencing that same jitter with that puck antenna, and then I connected the roof antenna, and then it went away.
Right.
It took some time for it to go away, but it did go away. So I personally think it's a firmware issue, that it's something with their engine, because it should not, like if you watch it.
The problem is it sounds like you're the only one having that.
Well, right, yeah. So obviously Trimble isn't going to do anything about it.
Well, but how can it be a firmware issue if you're the only one having a problem with it?
Because of the way that others use this in their applications.
It's just a GPS receiver. It should just work.
Well, right, but what I'm thinking, so it's very important for my software to look for the pulse per second where it thinks it's going to be.
Jonathan,
Now,
how much jitter are you talking about?
About 1 millisecond on the rising and falling edge.
Yeah,
1.5 milliseconds.
Yeah, no GPS should be putting out a millisecond jitter.
Yeah, right. The Belio Bodnar jumps back and forth by 20, 30, 40 nanoseconds.
Right. Now, even the gross ones are microsecond.
Well, no. What I mean is that from pulse to pulse, the rising or falling edge could be 1.5 milliseconds, positive or negative. Like the rising edge could occur 1.5 milliseconds before or after
what are you comparing it to?
So on the scope display, every second.
But what's your reference?
The reference is UTC.
No, but I mean, you have a GPS and you're looking at it on an oscilloscope relative to something else. What is your reference?
Oscilloscope in VLFRX tools.
But what's the oscilloscope triggering off of?
It triggers off of the UTC second.
From what?
Of the Raspberry Pi.
The Pi is jittering.
No, because I recorded it. I sent the recording to the author of VLFRX tools, and he played the recording back, and he saw the same jitter.
It's not the GPS jittering, it's the Pi jittering. The Pi is not that accurate.
Well, no, it's not. So when he plays it back on his oscilloscope, he uses his own UTC reference.
But your sampling frequency is probably drifting.
No, because the capture program keeps track of that, and there is no drift. Because also the
there has to be drift. No oscillator is perfect.
Yeah, but it's not causing this issue. There is drift, but the temperature is also kept stable inside the enclosure.
Well, is your Raspberry Pi being synchronized to a time server?
It's synchronized to the GPS pulse per second.
So it's not synchronizing to the internet.
It is. When it boots up, NTPD will synchronize to the internet, and then once the GPS gets a good fix, NTP switches over to the pulse per second peer.
Yeah, I'd look at your test setup, because I don't think GPSs don't jitter milliseconds.
Jonathan, I would agree with that too. You've got to have a good, stable source to compare. I have a very good GPS receiver I use here. When I tell you that, one is when one is bouncing around by so much, it's because I have a real good standard. It sounds like you don't have that.
Well, no. um, what I'm talking about is that from one pulse to the next. So let's say that a pulse per second occurs. The next pulse per second will occur either 1 minute plus or minus 1.5 milliseconds. The rising edge will occur plus or minus 1.5 milliseconds in time. So if you're looking at the pulse on a scope and it's triggering, you will see the pulse move, or the rising or falling edge move back and forth by 1.5 milliseconds. And it doesn't happen all the time. Like right now, I could bring up the scope display and I could show you, and it'll be stable. Now, it seems not to happen with it seems not to happen with the better antenna, but with poor signal conditions, it did happen. And just so that I wasn't crazy, I sent a recording of this. And I also have the pulse per second. So the pulse per second goes into the left channel of the sound card. So I sent him, I sent Paul a recording of this signal. And he also observed the jitter as well. Now, he could record a pulse per second signal from a U-Blox GPS and it wouldn't do this. And I could also send a recording when it's not doing it, and he won't see it. So what I was trying to convince Trimble is run the experiment in your lab and see what happens. But obviously
they don't have the experiment.
I told them how to set it up.
But they don't have the hardware. All they have is the GPS receiver.
Yeah, but they have an oscilloscope.
What are you triggering off of? If you're triggering off of the 1 pulse per second, there's no way it can jitter. You're triggering off of it.
It's triggering off of Pi's system clock.
Right, which jitters.
But it doesn't jitter so much as to cause
how do you know that? What do you have at Reveler? What have you referenced that to?
That's set with NTP and the GPS pulse per second. So
I suspect that you have NTP running all the time.
Yeah.
And it's resynchronizing your Raspberry Pi clock.
Yeah.
And it is only accurate to milliseconds.
Yes, that's true, because Linux, I don't know what Linux has, but I know that FreeBSD, you could compile the kernel that has a finer system clock. But yeah, I could show you what the pulse looks like. Let me just bring this up.
Yeah, if you can.
Because it's a really interesting problem that drove me nuts for a long time, and it even made me think that
you have more than one GPS receiver that has pulse per second output.
The only thing that I have in that system is the Res SMT360. Now I have a Res 720, but I didn't put that in yet.
Well, I just mean anything in your lab that you can get another pulse per second from, that you can check the two receivers next to each other.
I have another Leo Bodner GPS DO you can borrow, Jonathan.
That would serve the purpose.
Well, I would need an antenna and antenna splitter myself.
Well, you know, if you
we can get that.
Yeah, and by the way, any of the
I've got more antennas too.
Yep. You
So
can always use a separate antenna. Yeah. You can also the satellite satellite TV things. Satellite TV splitters that pass power through. You can use as a splitter if you have the right adapters.
Yeah, they also work in the L-band as well. Now see this? This is the actual scope display.
Right.
It's called VT scope. So the trigger source, it's currently set to universal time. So that's
which is coming from where?
That comes from the Raspberry Pi system clock.
That jitters.
Right, but notice now right now you can see each second the pulse per second stays in the same place, right?
Right.
When it starts to jitter, the rising or falling edge, or both, will jitter by 1.5 milliseconds. The VT time program that actually looks for the this pulse, it will produce an error and say that it missed it for that pulse when it starts to jitter.
Now I see down below resolution 1 millisecond. Is that your sample rate?
No, that's just how it displays. So I could change that. So the sample rate is 96 kilohertz. That's the current sample rate. That's the sample rate of the sound current.
Right, which is 10 microseconds.
Now, I've also experienced this too, using the higher sample rate sound card at 192K, and it showed the same thing. The same
well, I'm not surprised because if it's the system clock that's the jitter source.
But I mean, what I'm saying is that it's not necessarily this.
There it went.
No. That's not the jitter that I'm talking about.
What was that?
That was a lag in the display. This display is actually occurring locally at Nathaniel's house. So there's a lag.
Why did it just appear 10-15 milliseconds early?
Because that was a lag in the refresh of the display over the internet.
So this is not a real oscilloscope.
No, but I'm not saying that that's the problem, because so the issue here is that the utility that reads that actually looks for the pulse per second and resamples the signal with GPS time stamping offsets is seeing that it's missing the pulse. And when that happens, the rising or falling edge will jitter back and forth. So
what do you mean it misses the pulse?
Yeah, when it
there is not a pulse there.
It looks in a window here. I could show you that too. I could show you the log, because the sorry, sir, just bear with me. Let's see, where's the thing? There.
You have the pulse per second feeding into the NTP server, so it's the NTP's reference?
It's feeding into both the NTP server and the sound card. So this is the log output of VT time. So what it's doing is the PPS mean absolute distribution. Here, this value right here, this value should stay about the same, which it is from second to second, and that means everything's healthy. When it's not, when that pulse per second jitters, that value will go up to some wild amount, and then it will lose it for that second, go back into, so it's an ST2. Well, that's the run mode.
I see it's drifting right now.
Well, it is drifting, but that's normal. But when this happens, it's a wild drift that this PPS MAD value goes really high because it goes out of the window that it's looking for.
Well, NTP is supposed to resync when it gets off by a certain amount.
Well, this is an NTP. This is VT time.
I don't know what that is.
So VT time is the application that accepts input from the sound card. And it will look for the pulse per second signal. And once it finds it, it creates an offset value in the system clock timestamp of the stream, of the audio stream, and adjusts it so it is aligned with GPS time.
So offset, what's its offsetting to what?
It's so normally when you record the audio stream from the sound card, it's time stamped based on what the current Raspberry Pi system clock is running at, which is disciplined by NTPD.
Right.
But of course, that's not accurate enough. So what this does is this looks for the pulse per second signal, and it resamples the audio, so the timestamps align with GPS time. So that means that the internal timestamps on the output of this program, they are aligned to GPS time. And if you have other receivers running the same way, you could compare the signals, and they would be the same signal.
So where is it getting GPS time from?
From it's getting the actual UT value from, well, so it's getting the second value from the pulse per second signal that it finds, and the rest, the other portion of the time, comes from NTP. So that's how that works.
Yeah, but where is that one coming from? You say the NTP is being synchronized off the pulse per second, or is it being synchronized off of internet?
It's synchronized off of the pulse per second, but it gets the full timestamp from the system clock.
But the system clock's not that accurate.
Right. So what this program does is it generates an offset value, so the timestamps are aligned to GPS time based on the pulse per second signal that it gets from the sound card.
Yeah. Well, I don't think it's the GPS receiver. I think it's your time synchronization software that's getting resynced, because that's about the amount of time that it would jump when it does that.
But I mean, why would that occur at intermittent times though?
It depends entirely on the different oscillators that are involved.
Because
which will drift with very strongly with temperature. Your Raspberry Pi clock does not have a good oscillator behind it.
No, but so this software depends on the pulse per second signal arriving when it expects it to.
Right, but the problem is not the pulse per second that it's syncing to, it's when it expects it to be. That's the problem.
Well, the thing
That's
is,
why I'm saying if you can get a second GPS receiver, sync them both up, put them on a real oscilloscope, you will see that those pulse per second, the pulse per second rise times will match within tens of nanoseconds.
Well,
and they will not move.
Well,
we can do that here, Jonathan. I have an oscilloscope here.
Yeah,
I have the other.
No, that's not necessary, because so Paul uses this same setup, but he uses U-Block's GPSs, and he has no problems whatsoever. He doesn't have this problem, and he also has the same Raspberry Pi 3 and its same oscillator and the same, everything's the same, except he uses U-Block's GPSs instead of Trimble. And he doesn't have this problem. In fact, he has a network of receivers in India with Pi 3s and the same sound card.
What I'm trying to say, though, here is that you need to do some ground truthing here. And maybe the Trimble is doing something funny, but you're going to have another accurate reference to look at it against. Putting it through this system, you have no idea whether the system's jittering, whether, or even if it is, where it's coming from.
Well, I don't have a usable scope here, but Nathaniel
I'm sure Nathaniel has a scope.
I've got a brand new one sitting right behind me that's just dying to be used.
He'd love to break it in.
I'd love nothing more than to use that with the Bodner GPS DO I have sitting in my office.
It'll have to be running constantly, and
no, it doesn't. Once you have the two locked up, put them on, and have them on the oscilloscope, you will see it will not drift.
It's a reasonably fancy scope. I think it's networkable too.
Well, no. But I mean, since this is an intermittent problem, it's not going to do it all the time.
Right.
It's.
Well, how often do you see this happen?
But what I'm saying, Jonathan, is we could get set up and running and have a data log everything.
Right.
Or,
Yeah, run it for a day.
Yeah, but that'll create a lot of data.
That's what it's for.
And the parts.
Jonathan, you're going to have to do the ground truthing. Trimble's not going to talk to you about this unless and until you really see that which part of your system is jittering.
Well, see, if I had a scope, I would give Trimble a video of the pulse.
You have a scope, Jonathan.
So that's why that I have to, but this sound card scope is just as effective.
No, it isn't.
Yeah, I was going to add to that. Sound cards are notoriously bad clocks, and if you're relying on that for sampling, it could be anywhere.
And you're using a 96 kilohertz sample rate, where what we're talking about is a gigahertz sample rate.
And I have a scope. I'm more than willing to. The scope was purchased specifically for this project. So,
yeah, the one other comment I'd like to make is that that pulse is not clean. you may have a electrical driving issue. It's got ringing and undershoot.
The reason for that is because there's a low pass filter enabled on it. If I disable the low pass filter, the pulse will shape up.
It's also got a high pass filter on it. That's why the it's has the exponential decays.
Well, but I mean, I could turn that off. That's a sound card function, and I could turn that off in ALSA, and that would go away, and the pulse would be normally shaped. So, but for the sake of the software, it looks for the rising or the falling edge. So I have it set to look for the rising edge.
Right.
And right now, since the pulse isn't jittering, it's. But I mean, my argument is that if Paul is using this same setup with U-Box GPSs and everything is fine, and I'm using a Trimble, and I get this intermittent problem, and his and my system are the same, I don't think that I have to.
I've used many a Trimble. They do not jitter by a millisecond.
Well, right, maybe
Raspberry Pi may be that much different from his Raspberry Pi that his is behaving right and yours is behaving wrong.
Right. This may just have the oscillators drifting in a way that's very benign, and you have yours just in a very bad relationship.
Suspicious of that Raspberry Pi.
Yeah, but the thing is, like, I could send you the recording, and you could run it through VT Scope.
That doesn't tell me anything. It really doesn't.
Take it over to Nathaniel's and then put it on his scope and run.
Yeah.
Yes, for safety.
That's what we do.
Well, that's something that we couldn't do.
Yeah, why don't we try setting up on Friday, Jonathan? You're coming over here anyway.
There you go.
We could do that.
Yeah, and I've got to spend a bunch of time under my desk just like playing with the strapping and, making sure devices are in the right spot. And I've got to work on configuring my, what do you call it? My magnetometer to upload to Bill's system. And while I'm working on that stuff, you can work on playing with the scope and the GPS splitter, and I can bring the other Leo Bodner GPSDO in here, and you can really have at it.
Well, so we'd have to reproduce the problem. We would have to use the L1, the puck antenna.
Mm-hmm.
And we'd have to set the scope up where the pulse would be in the same place. And my money, if I were a betting man, my money would be on the fact that even on a regular scope with a much higher sampling rate and possibly a stabler clock, it will still jitter.
Then you got 8 guys here to bet the other way on you.
Because my argument is why with the U-Blocks and Paul's systems, why are they fine, and why is it?
Well, don't wonder. Test it. Just try it.
Do the experiment.
Yeah, I'd be really interested to see. I actually have been looking for an excuse to use the scope and to use the GPSDO. So I'd love to try it out. I spend way too much time just playing with software.
Right.
And writing papers. Proposals.
Well, see, the reason why that I'm hesitant is because to set up the scope in such a way that it'll record what I'm looking for.
No, it doesn't. No, you see, you can put a scope on infinite persistence, and when it jumps, it will stay on the screen.
Right, right.
So you just accumulate it, let it accumulate for a day, and you see where it jumps. But of course, you know, millisecond is something I've never seen. I've seen computer clocks jump a millisecond. I've never seen a GPS jump by a millisecond.
But so let's say that it does happen on Nathaniel's scope, right?
Then I buy you an ice cream.
And Trimble buys you a new receiver. But I really don't suspect that Trimble is going to do that.
I understand it seems really weird. I get that. It was weird myself because I didn't even expect it.
Well, but as I say, it's not unexpected from a computer clock. It is unexpected from a GPS. So I think your computer is jumping on you.
So now keep in mind, I mentioned that it could be either the rising edge or the falling edge, or both.
Well, Trimble's not going to do that. It's going to be spot on.
If the computer clock had an issue, I would expect
it could resync. It could resync at any time, and it could be near your rising edge. It could be near your falling edge.
Put it on the scope and take a look at it.
Yep.
Not to change the subject, but Dave would talk about what sort of charge controller you're looking at for the noise, RF noise, because I'm starting to look at getting a charge controller in here and a battery and a solar system to power things in here. And, you know, I don't know whether the thing's got noise or not. And if you've got something that's low noise, I'd like to know about it so I don't go and buy a bad one before without knowing anything when I start.
Yeah, I'm just beginning on that. We've got a wind turbine that they swear up and down on a stack of Bibles that it doesn't make noise. But as I say, one man's quiet is another man's raucous. So, and they, you know, different solar controllers. We're also doing solar coupled with wind, and various solar controllers can be noisy or not. And you know, they're trying to get me to use a pulse width modulated rather than a MPPT, but the MPPT is inherently filtered, whereas a PWM, the voltage is jumping all over the place.
All kinds of stuff at you.
Right. So some of them are noisy, some of them aren't. And yeah, this was an interesting thing that I was just talking with TJ Rogers, who's started Cypress Semiconductor. Now his big thing is the microconverters on solar panels, so that each solar panel actually is grid tied. And he swears again that, oh, they don't make any noise, but we actually know that they do. And you have to put a lot of ferrite on them to quiet them down.
Yep.
I'm going to say 73.
There's a QST article on quieting solar panels down. So
yeah, I'm going to say 73,
okay.
Everyone. Thank you.
Thanks, Nathaniel.
I'll see you later.
73.
Yep.
73.
You don't have any idea whether these grow watt charge controllers are noisy or not, do you?
I don't.
Okay.
What's the company?
Grow watt.
Grow watt?
GROW Yeah, GROWATT.
Uh-huh. Yeah, I do not.